Hokie dokie. In this problem, or before we get into this problem, they say need help factoring, check out, blah, blah, blah. So I would definitely recommend knowing how to factor before we go into this. I'll talk through it a little bit. And I don't know if this material is any good. I'd probably just say check out someone else's YouTube videos on how to factor. But all right, let's jump into it. So what we're going to do first, because they say need help factoring, that's kind of a hint into how to approach this problem. When you see this limit of this quotient here, what we're going to do is first rewrite it as the limit as x approaches 1 of, we're going to factor the numerator and factor the denominator. So looking at the numerator, this is how we factor. We need two numbers, so we'll start with x terms first. We need two numbers that multiply to 3, and those two numbers must also add to -4. So the way to approach this really is first kind of mentally go through all the factors of 3. Well, 3 is prime, and so really it only has 1 and 3 as its factors. So 1 and 3 are the values we will put here. But then the question is, will they be +1 and +3, +1, -3? What are the signs? Well, if 1 and 3 need to add to -4, then that means both of them must be negative. -1 times -3 is +3. Negative times negative is a positive. And then -1 plus -3, it's basically like adding 1 and 3 in the negative direction. So that's the numerator. Let's go ahead and do the same with the denominator, starting with our x terms. And then we need two numbers multiplying to -2. So probably 1 and 2. But we just need to figure out which one is negative and positive, or vice versa. So if it's -2, that means they can't both be positive and they can't both be negative, because that would result in multiplying or a product of it'd be a positive product between those two numbers. So we need just one of these, 1 or 2, to be negative. So we need 1 and 2 to add to +1, because that's the coefficient for the x term. So if we have a -1 plus 2, that'll get it into the positive value. So -1 plus 2 is +1. All right, let's keep going. So now in the numerator and denominator, what we'll do is cancel out any factors that we see in common. What we're left with is the limit as x approaches 1 of x minus 3 over x plus 2. Now usually when you see a limit, to evaluate, the first thing we do is plug in, or how we'll evaluate this is by plugging in x equals 1. So as x approaches 1 is almost the same thing as just plugging in 1 to what we have here. So what we'll have is 1 minus 3 over 1 plus 2. 1 minus 3 is -2. 1 plus 2, 3. -2/3 is our answer. If you have any questions, please let me know. We're going to go ahead and work out 2 more examples. So stay put. So again, same idea. Numerator, we're going to factor. Denominator, we are going to factor. So on top, we need two numbers multiplying to -3. So definitely 1 and 3. But they need to add to +2. So the smaller number would be negative. The greater number would be positive. So it keeps us in the positives, specifically adding to +2. -1 times 3 is -3. -1 plus 3, +2. All right. And the bottom, two numbers that multiply to 3. Again, 1 and 3. But in this case, they need to add to -4. So in this case, they must both be negative. -1 times -3 is +3. -1 plus -3 is -4. All right, so we have matching terms top and bottom there. X minus 1's cancel. We're just left with x plus 3 over x minus 3. And again, we basically just plug in the x value that they provide us. So in this case, it is 1. So we do 1 plus 3 over 1 minus 3. We get 4 over -2. 4 divided by -2 is -2. break out the eraser to see that C is our answer. All right, let's do one more. Oh, and the answer just showed itself, but then it covered itself up. All right, let's see if we can get there algebraically. Numerator factors in 2. So this is a good one to see because it's a little bit different. It's still kind of the same argument. We need two numbers that multiply to -9, but basically add to 0, because it's like there's a 0x in the middle. And so numbers that multiply to -9, but cancel out, they must be opposites of one another. In other words, one must be positive and one must be negative, and they must both be the same number. So 3 times -3 is -9. 3 plus -3 is 0. But really, you should just kind of memorize this as a difference of two squares will always give you the square root of that back end number. So x plus 3, x minus 3. On the bottom, we have x, we need two numbers multiplying to 6. So we could do a couple different things. We could do 1 and 6, we could do 2 and 3. We just need to figure out which one is correct in terms of adding to -5. Well, the first thing we could say is that because 6 is positive and 5 is negative, we know that these must both be negative, because they can't both be positive to give us +6, because they wouldn't add to -5. So they must both be negative, because negative times negative is still positive, and the sum should still be negative. So we need two numbers multiplying to 6 but adding to -5. So if we tried 1 and 6, -1 plus -6 would be -7, so that doesn't work. So our only other option is -2 and -3, because -2 times -3 is +6. -2 plus -3 is -5. So we can cancel x minus 3, and we are left with x plus 3 over x minus 2. And the x value we are plugging in is 3 in this case. So we get 3 plus 3 over 3 minus 2, so we get 6 over 1, which is 6. So a little obvious note about this one based on these three examples is that if you factor the numerator and denominator and you don't find anything that cancels out on top and bottom, double check your work, because there should always be something that cancels out on top and bottom to leave you with something that you can plug in the x value to. Something important to mention that I did not mention is that had we plugged in 3 at the very start, it would have created a 0 over 0 case, because plugging in 3 here and here would have given us 0 over 0, and that's why it requires us to factor each time. Yeah. All right. If you have any questions, please let me know.